Hi, I'm Phil, and today I'm going to talk about building your own electronic scale. So if you're interested in science, either physics or chemistry, or any other branch of science for that matter, you'll eventually have to get one of these, which is an electronic scale. And this scale is pretty good at measuring masses, quite accurate and stable. So 100 grams from a calibrated mass comes up at 100 grams, pretty good. But I wanted to build my own, and I've attempted about 2 of these so far. The one on the right here is the M5 stack scale, and it uses a M5 stick C computer, which is this one here. In the middle there's a load cell, which is has a full scale of 5 kilograms, and next to that there's a weight unit from M5 stack, and it's both an amplifier and a analog to digital converter with 24 bits of precision to give you quite accurate readings. Now, as a complete kit from M5 stack, this works very well. But in this arrangement, I've got the weight unit going into a M5 stack fire computer, and it's also has a real-time clock and a time of flight laser sensor. So in this arrangement, I'm going to use it for verifying and doing experiments with Hooke's law. So what's going to happen is that the masses, the incremental masses, can be weighed, and they can be logged by the fire computer, but also the time of flight can actually have a look at where the masses are suspended. So that's one experiment I'll conduct. And the difference here is that the weighing is part of the experiment. Now today I'm going to talk about another one. This is the second one, and I only built this one yesterday. This is from Keyestudio, and it's a similar to the other one. It has, you can recognize in the middle here, the load cell, 5 kilograms again, and it's got a H711 amplifier and 24-bit ADC, the same one that M5 stack uses. It's got a LCD, and there's underneath that there's another layer of electronics with a push button here, and next to that you can't quite see is a Arduino compatible computer, which is this one here. So Keyestudio make their own Arduino computer. It's UNO compatible, and it's on the bottom layer. And I put the kit together, but unfortunately the software quality leaves a lot to be desired, and I couldn't get any of it working with the code that was available on the Keyestudio website. But eventually I got it to work, and there are generic drivers and examples libraries available for the HX711 weight unit, which is quite popular. And you can get the load cells in various sizes. So here's a really big one. Yeah, there's only 3 kilograms maximum weight, which is quite strange compared to the 5 kilograms, which is much smaller. And here another one I'm building, a very, very small one here, uses the Keyestudio HX711 amplifier ADC weight unit. So these are some of the units, and just to put this one into action, you can reset the micro and return the reading to 0, and then you can put a calibrated weight and see what the readings are. So we need to calibrate this one again. It's about 0.3 of a kilogram out, or 0.5 of a kilogram at the moment, out in its measurement. And now what's interesting about this is that I've hooked this up to Excel on a computer over here, and you can get the results. So the results are going to the plot data acquisition on Arduino, and they are also compatible with Excel. Okay, so what I'll do next time is give you a demonstration of the best of these, which is the M5 stack scale on fire, and hooked up to the real-time clock and the time of flight sensor, and I'll show you how that's been used with Hooke's law as a physics experiment. Okay, that's all for now.